Hello everyone, I'm Jas Chabra. I'm a principal engineer in AWS Machine Learning, working on Code Guru and DevOps Guru services. Today I'm here to talk about how at Amazon we use performance analysis to build efficient applications. In particular, I'm going to talk about how we use profiling of applications, always on, always available profiling, to really make our applications cheaper and faster. First, I'm going to talk about why are we such big fan of profiling. Why do we think that profiling in production, so that profiler is always available, always on, is super important and very useful to make your application cheaper and faster. I'm also going to go through some real world stories of how at Amazon various services have used this profiler to make our applications cheaper and faster. So why are we such a big fan of profiling an application? At Amazon, we think of engineering priorities in kind of following order. Most teams think of it in following order. Number one for us is always security. That's something we never ever compromise on. Second is durability. We want to make sure that we never lose customer data. Then comes availability. We want to make sure that our applications and services are always available for customers to use. And last but not the least is speed and efficiency or cost. Essentially, how to make our applications cheaper and faster. And that's going to be my focus in this talk. At Amazon, we are always thinking about how to make our customers happier. In fact, customer obsession is our number one leadership principle. So what we have found is that by profiling our applications and trying to find these efficiencies, we can make our applications faster. And faster applications always make customers happier. Here is an example of how an AWS service used Amazon Code Guru Profiler to reduce the 99th percentile latency by 3000 milliseconds. So we worry not just about an average customer, we worry about the 99th percentile customers to make sure even they get the really good experience that they expect from Amazon. I'm going to go through this in part of my real world stories. Another aspect of being customer obsessed is we want to always keep on reducing our costs. We do not want to leave any money on the table because we want to pass the savings on to you. This is an example of where we achieved a lot of cost reduction in our services. This is one of the services that I handle. In this service, we have lots of Kinesis streams, at the end of which are set of workers which are processing different shards in that Kinesis stream. We noticed that in some of the streams, the workers were using up very high CPU. So as you notice on the top graph, the CPU usage went all the way up to 80-85%. And because of that, the read lag on those Kinesis streams also went high. So when we looked at the profiles, what we found was that we were spending a lot of time just excessively logging different aspects of the application. And we definitely don't want to be spending too much time logging. It's important, but you don't want to be spending a whole lot of time just logging. That's not the value add to the customer. Once we fix that, you can see the dramatic difference it had. The CPU usage went down all the way from 80-85% to low single-digit CPU percentage usage. The read lag went down way below 1 minute, which is exactly where we wanted it, because it's a real-time stream processing application. At the end of it, we were able to save a lot of infrastructure cost, pass those savings on, and make our application faster. So we made our application cheaper and faster. A lot of times what will happen is, again, being customer obsessed company, we are listening to our customers and we are trying to deliver new and new features to the customer. And a lot of times what will happen is when engineers build these new features, they'll find that some new feature or some new aspect of the service needs a little bit more resources than they expected. So they'll add more hardware because that's the fastest way to deliver this feature to the customer. Many other times, services grow faster than we expect, and sometimes more traffic shows up than we expected. So services get under high load. The quickest way to fix that is, again, to add more hardware. And that's the right thing to do at that time. But as this continues, what we found is that if we are not looking at our infrastructure cost all the time, teams will struggle to keep it down. And we definitely want to keep our infrastructure costs down to pass on these savings to you. So I talked about why we are such a big fan of profiling our applications to find efficiencies in the applications. But why in production? What's the reason that we want to have always on, always available profiling in production environment? So one of the big learnings we had is that pre-production environment and production environment are hugely different. The environment settings are different, and even the traffic patterns are different. Sometimes some teams have tried to emulate the traffic patterns in that show up in the production environment in a pre-production testing or beta environment, but it's frankly a losing battle because the traffic patterns that your application sees in real customer environments or real production is changing all the time. It's different in the morning, it's different in the evening. Shifts it shifts between weekdays and weekends. In fact, your customer mix is changing all the time. So there is trying to keep up with those changing traffic patterns and emulate them in pre-prod environment is kind of a losing battle. You'll struggle to keep up. So what we realized is it's better to have the profiler or performance analysis tools running in production. So you get the real world view. So we also find the profile of the application as it behaves under real traffic pattern or real traffic load of the customer. And that another thing we found is that many times when extra load shows up, application can sometimes behave in an unexpected manner. And once the load goes away, we want to figure out what happened. And it's hard to go back in time and understand what happened because you've lost, you can't, unless you have a time machine, you can't really go back in time. So what we found is when we have profiler running all the time, always available, we can easily go back to the past profiles and see what happened under the traffic load. Why did our application not behave as we expected it to? And we can fix it, we can improve it, we can make our application better and faster. One of the objections sometimes some teams will bring up is, hey, if I run it in prod, will it impact my service? The answer is, if you use a sampling profiler, which is what we do, and that's another reason we are big fans of sampling profilers, then that sampling profilers typically have near zero overhead on the service. Example of that is CodeGuru Profiler, which I'm going to walk through. Because of this near zero overhead on the service, it's okay, and we have found that it's perfectly fine to run it in production. In fact, across Amazon, thousands of teams are running Profiler in production and benefiting from its features. One other interesting thing that we noticed is that there is always this tension between things that are important but not urgent. And trying to reduce cost or increase speed is kind of falls in that bucket. Remember, I walked through the Amazon engineering team priorities. One of the other things that I missed in there was about delivering new product and features. We are always listening to our customers, so we are always trying to build new features or new aspects of into our product that our customers are asking for, and we are in a hurry to deliver that value to the customer. As a result, a lot of times these important but not urgent things like trying to reduce your infrastructure cost or gain more efficiency, we have limited time for it. So how do we get around that? Essentially, it boils down to, do we want to make our applications better for our customers by adding more capabilities into it, or make it cheaper and faster? What we have found is we can actually achieve all three. And how have we done that? What we found is the best way to do it is to build a culture around it. And the number one part of making a culture around it or building a culture around it is to make it easy. And that's where always on, always available profiling comes in. If you're running your profile, if you're running a profile in production all the time, then you will be able to use that profile and be able to understand or find more efficiencies in your application. Another aspect is building mechanisms around it. At Amazon, we always think in terms of mechanisms. We talk about good intentions are not enough. Good intentions generally don't achieve the thing you are targeting. Mechanisms are what matters. So we also build some mechanisms around it. And the couple of mechanisms we built is one is we review our infrastructure costs periodically, and that kind of keeps teams thinking about infrastructure costs and looking for these efficiency gains. Another mechanism we found is just sharing our wins, celebrating our successes in these efficiency gains. And that's very, very critical because that creates an engineering culture around it where engineers are interested in finding these wins and sharing their learnings across the company. We have lots of email lists going on within the team across the company where we share significant operational wins and talk about what the lessons we learned from them, so we can create a culture around sharing these lessons, finding these efficiency wins. How easy have we made it? So I was recently talking to AWS senior P, David Yanisek, and he was telling me how in a few of the internal services inside Lambda that he handles, he has Profiler running always on, always available in production. And occasionally he just sits down during his coffee break and looks at the profile, and he's able to find interesting areas where he can gain efficiency in his application. A recent example he was sharing with me was that he was looking at in one of his coffee break, he just opened up one of the application's profiles and saw that an area of application where regex was taking up a lot of time. So he looked at the regex, and just by changing a couple of characters in the regex, he was able to gain significant efficiency in his application. So that's how easy we have made it, by having always on, always available profiling. As a result of this culture change, what we have found is that thousands of applications across Amazon are now using CodeGuru Profiler. And it has been used to debug hundreds of operational events. We actually scanned through many of the retrospectives of operational events to look for CodeGuru Profiler mentions, and we found hundreds of places where it was mentioned. Similarly, we looked through the performance wins that are shared across the company to look for CodeGuru Profiler mentions, and we again found hundreds of these scenarios. And we believe this is likely a small fraction of where it's being used in practice across Amazon, because not all retrospectives are shared across the company, not all performance wins are shared across the company either. In fact, we have ended up saving tens of millions of dollars or maybe even more across the company just by using Profiler. But why sampling profilers? To really understand it, let me talk about how to think about profilers from the aspect of how they sample or how they get their data for profiling. Profilers can be categorized in multiple ways, but I'm focusing right now here as to how they actually gather the data. So one of the most common forms of profilers is event-based or tracing profilers. Another is the sampling profilers. The tracing profilers, what they do is, or the event-based profilers, they hook onto different events within your application and then gather data at those events. As an example, a tracing profiler might hook onto entry point of a method and the exit point of a method and measure the time it took to run the method, also different thread states, and then collect the data and show you the profile. On the other hand, what sampling profilers do is they just sample your call stack at random intervals of time and then collect that data into the application profiles. Since tracing profilers are hooking onto your application, they can have quite a bit of overhead. Sometimes some of the tracing profilers may even have overhead up to 100, 200, 300% of your application. On the other hand, since sampling profilers are only sampling at infrequent random intervals of time, they have very little overhead on the application. Here is how CodeGuru Profiler makes sure that the overhead on the application is very minimal. It's so negligible that you can comfortably run it in production. So the way CodeGuru Profiler works is that there is an agent that's linked into your application, and that agent is sampling at random intervals of time and reporting back these samples onto the CodeGuru Profiler service. The agent makes sure that the sampling rate is such that CPU load on your application is less than 1%. In addition, if you have a decent enough cluster size or number of machines, it makes sure that it's only sampling a random subset of those machines. So not only is the overhead on the machine where it's sampling is low, but also because it's sampling only a random subset of the machines, the total overhead on a service is typically ends up being a fraction of 1%. And that is the reason we have been able to run it across Amazon in production with almost with no impact on our services. So just to recap, so sampling profilers, the reason we are big fans of it it's got very little side effects or almost no side effects and low impact, so we can easily run it always on, always available in production. Now there is a caveat: it can have potential inaccuracies, but we can avoid it, and we do avoid it by random sampling. So we sample randomly at random intervals of time, and we aggregate these samples to make sure we have statistically significant profiles before we report them, and that way we avoid these potential inaccuracies. Here is a visualization example of what the profiles look like. And I'm going to go through that in a demo and show you how CodeGuru Profiler visualizations can be understood and used in your own services.
Now let's go through how CodeGuru Profiler can help you understand your application's performance and find areas where you can gain more and more efficiency. Here is one of the visualization that CodeGuru Profiler has. This is called a flame graph visualization. The best way to understand a flame graph visualization is to first jump to a place which you're familiar with in your program or application's call stack. So for example, here I'll go to main lambda.run. That's kind of the entry point of my application. And I notice that main lambda.run, above that are two other rectangles, image processor run and image processor extract task. What this is telling me is that main lambda run called image processor run, which in turn called image processor extract task. So essentially I'm seeing the view of my call stack as to how which method called another method and so on. In addition, the width of the rectangle is proportional to the CPU time. So essentially I can look at any of these and this visualization and just by at a glance tell where my program is spending most of the time. So as an example here I can see that in my application, which is essentially picking off tasks from SQSQ, image processing tasks, and then processing images, I'm spending most of the time just extracting and grabbing the tasks from SQSQ and very little time processing them. I expect it to be reversed because frankly the real work or the real value add that my application is doing is in image processing and not fetching tasks. So there is something wrong here. But already it's given me clues as to what I need to focus on. In addition, here if I go and scroll up, one other cool thing is that if, for example, I go to the zip file entry, it shows me all the other portions in the call stack where zip file entry, get entry was called. I can go here and see in this portion of the call stack, zip file.get entry consumed 5.2% of the CPU, and in this portion it consumed 5.8 and so on. You can kind of get a sense that zip file.get entry is consuming quite a bit of time, but it's all divided up into different portions of my call stack. So it's hard for me to kind of keep track of that and understand what's happening. So for this purpose, there is another view called a hotspot view. Here it shows the top of the call stack near the top of the visualization. So zip file.get entry is essentially shown at the top, and you can right away see that zip file.get entry is using up 19.6% of the CPU time, of the total time. And that's a lot of time. So maybe there are some efficiencies I can gain here. Maybe I can um, get a better implementation of zip file.get entry or dive in deeper and understand what's happening there. In addition to the standard CPU view, CodeGuru Profiler also has another view called latency view. This view can really help you understand how to improve your application's latency. The other view was more focused on how to reduce the CPU usage of your application or different portions of your application, but this view really shows more of a thread state view, which helps you figure out where exactly in an application are you getting blocked, where are you waiting for something, etc. And that can help you really reduce latency in your application. So for example, here the color coded red is the runnable. So this portion of my application I spent running, while on the other hand here, which is the green colored portion of the call stack, I was waiting on something. And typically, if I'm spending time waiting on something, I may be able to improve and gain some efficiency in my application by either making it asynchronous or doing some other improvements. So now that we walked through how very quick view of how you can use different visualization to understand your application, let me kind of touch upon another very cool feature of CodeGuru Profiler. So in the previous two visualizations, programmer has to understand the application, go through the visualization, and dive deep and understand which areas of application can the programmer find more efficiencies in. CodeGuru Profiler goes one step further than that. CodeGuru Profiler analyzes your applications automatically and based on our algorithms finds many areas where you can fix or improve to gain more efficiency. As an example, if you remember, when I was looking at that profile, I realized that a lot of time was being spent just in fetching the tasks from the SQS queue. The first recommendation itself gives me a great clue as to why that was happening. So if you look at this, what this first recommendation is saying is that in my application, I'm spending almost 20%, 18.57% to be exact, of the total time on on just creating application service clients. This is not this is kind of an anti-pattern because in an application that's using AWS services, you want to create the client once and just reuse it across your service. So I can right away see that I can gain huge efficiencies in my application just by following this recommendation. And when actually I did it, I found that it ended up reducing a lot of my CPU time. And there are other similar recommendations here, like I'm spending a lot of time just debugging and tracing in my application. That's just too high, close to 5%. Really, typically it should be less than 1%. And I'm recreating my loggers. Again, that's a bad idea, similar to the recreation of the AWS SDK client. So as you can see, not only can CodeGuru Profiler help you look through visualizations that we have and help you find areas of efficiency, but also CodeGuru Profiler uses our own models and algorithms to to find areas of efficiency for you, so you can just follow our recommendation and save a lot of cost, gain a lot of efficiency.
Now that we saw how CodeGuru Profiler works and how its different visualizations can be used and recommendations can be used to make our applications cheaper and faster, let's walk through some real world examples and real world stories of how we at Amazon have used it to make our applications better, cheaper, and faster. So, if you remember, I talked in the beginning about a service which was very worried about its 99th percentile latency for one of the APIs. As you can see, this graph, the 99th percentile latency is pretty high. It's going all the way up to 5 seconds. So when the team ran the profiler, they found something very interesting. What they found was that in their Lambda function, they were publishing CloudWatch metrics, but they were publishing it in a synchronized block in Java. As a result of that, all the other threads that were doing the real work just got blocked on this synchronized on this metric publish aspect. And because of this, because they got blocked, they were not really doing any real work. So the latency went very high. So once the team figured it out, the fix was relatively easy. They just moved the part where they published the metric, that method call, into the end of the actual function, the Lambda function. As a result of that, the work could continue independent of the publication of the metric, and the 99th percentile latency, as you notice, went down drastically. In fact, the spikiness is also down in 99% latency, as you notice on the right hand part of the graph. And what is also not shown but happened was the 50th percentile latency also went way down. So not only did the 99th percentile customer benefit, but all the customers benefited from this improvement. So they were able to make their application faster just by using Profiler. So there was one Amazon retail service which had been running for quite a while. So as typically happens for a service that's in existence for quite a while, there are always new features coming in. There are always new requirements from customers coming in. So they were adding those, and slowly they noticed that as they were adding these requirements and features and growing faster than they expected, their infrastructure costs were growing more than they wanted. Also, they started noticing some latency delays in some of the APIs that they didn't like. So they decided to look at their profiles. And what they found was very interesting. As you can see in this profile, it's very obvious that the garbage collection is taking up a huge amount of CPU. Here it's taking up about 65% of total time. That's too much for garbage collection. Then another thing that they found, which actually CodeGuru Profiler found by scanning their profile, was that in a AWS SDK, clients by default save the response metadata in the cache set. This is very useful when you are trying to debug or in a pre-production environment, but you do not want it in production environment. So CodeGuru recommended that they remove this, they change this configuration, and that would save about 2.8% of CPU. The third thing they noticed was that they were using up more time in logging than they wanted. Typically, you want less than 1% of total time, CPU time used in logging. They were using more than 2% of the CPU time in logging. Once they fixed these three issues, the change was dramatic. The garbage collector count, as you can see in this graph, went down to a fraction of what it was. The latency also went down to a fraction of what it was. At the end of it, they ended up with 25% lower infrastructure cost, which is great savings that they could pass on to their customers. Their 99th percentile latency went down from 2500 milliseconds to 250 milliseconds. So 1/10, just a fraction of what they had. So they ended up making their application cheaper and faster. Another interesting real-world story is where there's this service which is part of the Amazon retail checkout side, and they got a little bit of unexpected customer load, and they started noticing there was some high latency on the checkout, so their alarms went off. So the immediate mitigation, of course, which you would typically do in such a scenario, is they just added more hardware so customers wouldn't see any impact. But after they added hardware, they decided to revisit the profiles of application to see what was the reason for this issue. What they found was pretty interesting. What they found was that due to a recent change in the application, they were using up a lot of CPU time, lot of total CPU time, just in logging. So once they fixed that issue, they were able to reduce the latency and scale back the fleet to below what they had even before the event. So they were able to, again, another example of where a service was able to make their application cheaper and faster. So what are the key takeaways here? One of the big things is the reason we are such a big fan of Profiler is that it hits so many of our customer obsession principal aspects. It saves infrastructure costs for us. By using profiling, we can save a lot of infrastructure cost and pass those savings on to the customer. We can make our application faster, so cheaper and faster. And in addition, A lot of times, as you saw in the last example, it helps us debug and catch operational issues even before they happen. And another thing we, of course, learned is that it's not only important to profile, but it's very, very important to also profile in production. Profiling in production means you have an always on, always available profiler. You are getting your profiles in a real workload in a real environment under customer traffic conditions. And of course, because CodeGuru Profiler is a sampling profiler, it won't impact your service. And that's why we are big fans of sampling profilers, that we can run always on, always available in production to make our applications cheaper and faster. That's the end of my presentation. Thank you.